One of the things that is very powerful about Blender and ZPy used in concert is the ability to automate the randomization process that you're going to need for a synthetic data simulation. So I'm going to show you a really quick and easy way to randomize your data. And as you can see, I've kind of simplified our scene a little bit here so that we can really dig into this. So first we need to make an object for our computer to be spawned on. So we're just going to go add, mesh, plane. As you can see, we have a plane right here. And if we go into our scale, we can scale it up to cover the area that we want our computers to spawn in. Cool. And so then what we want to do after we've scaled it is go to Object, Apply, Scale. And this pretty much syncs the object data with all of the other elements of Blender so we don't get weird things happening. The other thing we want to do is make sure our object is also at 0 scale. So if you look at the item tab over here, you'll see that the scale should be at 1, 1, 1. And if it's not, if you hit Object, Apply, Scale, it'll all reset. So then what we're going to want to do is select our plane, make sure it's the plane that we want to spawn objects on, and then we're going to go into the Geometry Nodes tab over here. This spits us into our Geometry Nodes workspace, and it's using Geometry Nodes that we're going to really get that randomization feature working for us over here. So making sure we still have that plane selected, we're going to hit New, and that creates a new geometry node for us. And this node network is kind of how we're going to manipulate our data here. So the first thing that we want to add is a point distribute. So we're going to add our point distribute to our geometry, see how it's kind of flowing left to right here. And as you can see in our viewport, it's added a bunch of points, and on each of those points is where our computer geometry is going to be spawned. And as you can see, if we manipulate the seed function here, they sort of jump around to random locations, giving us, infinite spawn points that we can manipulate to our favor in our synthetic data simulation. So the next thing that we want to do is put our model on each point. So we're going to go Add, Point, Instance, and as you can see, we don't even see our points anymore. But what the computer wants you to specify is what object to spawn on each point. Right now, there's nothing, which is why we see nothing. So if we go to this little eyedropper tool, eyedrop, select it, and suddenly, let's move our original object kind of out of the way over here, we have a ton of computers spawning on this plane here. And we can just like roll through our seeds and see that they're moving, changing. Something that you might want to change is, as you can see, computers are kind of spawning on top of each other. If you go to random and change it to this object, you can specify a distance. So you can sort of like, if objects are colliding, the point distribute will delete them depending on what distance you've specified over here. You can also add to the density, so we're going to get more points with more computers or less points with more computers. And that's pretty cool. So we can really randomize where our objects are appearing. But another really cool thing that we can do is, instead of using an object in this point instance, we can use a collection. So if we hit this collection over here, we want to uncheck whole collection. And then if we specify a collection, and I've already kind of made one over here with 3 computers that have varying coloration on them. So we see a red, a green, a blue one. And with this specific implementation, I wanted to showcase the idea that the computer is spawning the geometry at the point that is specified on your original model. So as you can see, we can see our origin point is this little dot over here, and the geometry node system is spawning the computer at that point. So what we can do to change that is we can do set origin to geometry, and we automatically get that a little better. And then if we want to further change that, if we go into Object, Edit, we can move that up so that the point is on the bottom. And now they're spawning correctly. And we could do that to all of our objects, and they would start to spawn correctly. But you can see really quickly the power of this geometry node system. With just 2 nodes, now we can click through and randomize where different color computers are spawning. This could be really useful for, say, a scene where you have a lot of different objects that you want to spawn randomly in different locations, sort of a classification problem that you're trying to solve. So many different implementations. And obviously the seed value can be manipulated in ZPy, and you can use that in your simulation to automatically create different values in each frame of your simulation. Now once we've got our geometry node set up, the thing here is that none of these individual computers are actually real geometry. They're instances of the original geometry that we specified in our collection over here. So in order to segment them as individual objects, one thing that you're going to have to do inside of ZPy is turn them into real geometry. So if we go to Object, Apply, Make Instances Real, can do that. And as you can see, we now have a real computer in every spot that our geometry node created. So it's really important that you're aware of the fact that the geometry nodes is not creating individual geometry. It's instancing it, and that you have to make the instances real for every frame in order to segment individual objects in your simulation.